Hello, this is Dr. Brown. In this video, we're going to go over test 4 practice, work all the problems. First problem is we have two fair six-sided dice. They're rolled. What's the probability that the sum of the two numbers on the dice is greater than 10? Well, we need to look at the possible outcomes that would give you a sum greater than 10. And you would start off looking at 6 and 6, and then a 6 and a 5, and then a 5 and a 6. The next possibilities would be 5 and 5 and so on, but the only ones that would be greater than 10 would be 6, 6, 6, 5, and 5, 6. There are 36 possible outcomes. 6 on the first throw and then 6 on the second throw, which is a total of 36. And there are 3 that would be greater than 10. So the probability, in fact, let's let E equal the event greater than 10. So the probability of E is going to be 3 out of 36, which is 1/12. Then we do the same throw and ask what is the probability that the sum of the two numbers is not greater than 10. Now you know that the probability of not E happening, which is given the event is E with a bar over it, it's going to be equal to 1 minus the probability of E. So this is 1 minus the probability of E is 1/12. So this is 12/12 minus 1/12 equal 11/12. Now, the two fair six-sided dice are rolled again. What are the odds of the sum of the two numbers on the dice being greater than 10? So the odds of E would equal the probability of E divided by the probability of E not happening. And this would be 1/12 divided by 11/12, which is 1/12 times 12/11, which is equal to an odds of 1 to 11. Chantel noted that there are 2 equally likely outcomes when you flip a coin, and heads is one of those outcomes. She concluded that the probability of getting heads on a flip of a fair coin is 1/2. What method did Chantel use? And this would be the theoretical method. Which of the following could not possibly be probabilities? Well, probability has got to be positive, and so that rules minus 0.44 out. And probability of an event has got to be between 1 and 0. So that rules out 13/7, which is more than 1. You can have a probability of 0, and you can also have a probability of 0.43. So our answer here is A and B. Which of the following events has a probability of 0? Well, A, the sun will shine all day on January 1st in Portland, Oregon. Well, you might think it's real cloudy and the sun's not going to come out, but the probability is always going to be, it may be very small, but it's probably going to be more than 0. Now, your chance of winning the lottery if you buy just one ticket is very small, but it's not 0. However, number C, tomorrow will be Monday if today is Saturday, has a probability of 0, because if today is Saturday, the next day is, of course, Sunday, and it's not Monday. So C is the only answer. So A is what you choose, C only. Every week, Joe plays chess with his father. Of the last 50 games, Joe has won 60% of the games. What's the probability that Joe will not win? Well, if E is the event that Joe wins, probability of E is equal to 0.6. So the probability that he will not win is 1 minus probability that he will win, which is going to be 1 minus 0.6 equal 0.4. Now, Sebastian lives in a rainy city. In this city, in 9 of the past 24 years, there's been more than 100 days of rain. What's the probability there will be more than 100 days of rain next year in this city? Give the answer as a fraction. Well, the probability is going to be 9 out of 24, which is 3/8. A group of people were asked if they had attended college. 200 responded yes, and 350 responded no. That's a total of 550 responses. Find the probability that if a person is chosen at random, they attended college. Well, this answer, probability of attending college. From this sample, it would be 200 out of 550. Which is 0.364. Okay, we have 2 marbles are drawn without replacement from a box with 3 white, 2 green, 2 red, and 1 blue. And that's a total of 8 marbles. Find the probability that both marbles are white. Probability that both are white is going to be the probability of first one white times the probability that the second one was white, given the first is white. probability the first is white is going to be, you've got 3 white ones out of 8. And then given that the first is white, there are 7 marbles left and 2 of them are white. So the probability that the second one is white, given the first is white, is 2/7. So multiply these and you get 6/56 equal 3/28. So the answer is D. Number 11, the following table shows results of a clinical trial for an allergy drug. What is the probability that a randomly selected person received no treatment or improved? Well, out of the 500, 100, which is 41 plus 59, received no treatment. And then the ones that improved were these, 145 and 85. So the probability, no treatment, or improved, equals 41 plus 59 plus 145 plus 85 divided by the total, which is 500. And this equals 0.66. Company wants to hire a software engineer, administrative assistant, and a sales representative. There are 4 possibilities for software engineer, 4 for the administrative assistant, and 3 for the position of sales representative. So the total possibilities would equal 4 times 4 times 3 equal 48. A 3rd grade class has 22 students, 12 girls and 10 boys. 2 students must be selected at random to be in the fall play. What is the probability that no boys will be chosen? Order is not important. Well, the number of ways to pick 2 girls, that would be no boys, of course, out of a group of 12 girls equals a combination of 12 things taken 2 at a time, which is equal to 66. Now the number of ways to pick two people boy or girl out of the 22 students equals combination of 22 things taken 2 at a time, which is equal to 231. So the probability of no boys being picked is going to be 66 out of 231, which is equal to 2/7. A poker hand consists of 5 cards dealt from an ordinary deck of 52 playing cards. How many different hands are there consisting of 4 hearts and 1 spade? Well, you have in a deck of cards 13 hearts. So the ways to get 4 hearts from 13 hearts is equal to combination of 13 things taken 4 at the time, which is equal to 715. We have 13 spades. So the ways to get 1 spade out of 13 spades equal combination of 13 things taken 1 at a time, which is equal to 13. So the total ways to get 4 hearts and 1 spade is going to be equal to 715 times 13 equal 92.95. Now we have figure out how many different 4-topping pizzas can be made if there are 13 individual toppings to choose from. No topping is used more than once, and the order of the toppings on the pizza is unimportant. So this would be combinations, and it'll be a combination of 13 things taken 4 at the time, which is 715. Number 16, there are 5 members on the board of directors. If you need to elect a chairperson, a secretary, and a treasurer, how many different slates of candidates are possible? Well, for the chairperson, we have 5 choices. Once the chairperson is chosen, you need to choose a secretary. So there are 4 left to choose from. And then when you get to the treasurer, you have 3 left to choose from. So the total number of different slates would be equal to 5 times 4 times 3 equals 60. Now we're playing a game, choosing marbles from a bag. The game, but the bag contains 2 gold marbles, 7 silver marbles, 23 black marbles. Someone offers to play this game. You randomly select 1 marble from the bag. If it's gold, you win $4. If it's silver, you win 2. If it's black, you lose $1. What's your expected value? Well, we need to look at all the outcomes. And for each outcome, figure out what the value of that outcome is. And then calculate the probability of that outcome. Well, one outcome is you pick a gold. The value of doing that is $4. The probability is you have 2 gold marbles, and there are a total of 32 marbles. So the probability is 2 out of 32. And at this point, I'm not going to reduce that. I'll show you why. Another outcome is silver, and its value is $2 because, and the probability is 7 out of 32. The last possibility is that you draw a black ball and you lose $1. And this probability is 23 out of 32. So the expected value is going to be $4 times the probability of that outcome, which is 2 out of 32, plus $2 times the probability of that outcome, which is 7 out of 32, minus $1 times the probability of a black being picked is 23 over 32. So the total is going to be 8 plus 14 minus 23 over 32, which is equal to minus 1 over 32, which is minus 0.03125. So we expect loss is about 3 cents. Now you're looking at buying a raffle ticket. A raffle ticket costs $2. There'll be 1 winning ticket worth 1,000, 3 tickets worth 100, and 5 winning tickets worth $20. 1,000 tickets were sold. What's the expected value to you of 1 raffle ticket? So now again, we need to look at outcomes. The value of that outcome, and then the probability. First outcome would be to win $1,000. And the value of that is 1,000 minus the cost of the ticket, which is $998 after you subtract $2 off the 1,000. Its probability is 1 out of 1,000. You could also win $100. Its value would be $98. And the probability, since there are 3 tickets, would be 3 out of 1,000. You could win $20. That value would be 18. And the probability of winning one of those 5 tickets is 5 out of 1,000. And you could not win anything, so you would lose $2. And the probability of that is 991 out of 1,000. So the expected value is equal to 998 times the probability, which is 1 over 1,000, plus 98 times 3 over 1,000, plus 18 times 5 over 1,000, minus 2 times 991 over 1,000. So if you add all these up, you get minus 600 over 1,000, which is minus $0.6, or which is 60 cents. So the expected value is minus 60 cents. Now the next problem is a question about a normal distribution. What percentage of the data is between minus infinity and plus infinity? Well, the normal distribution is this bell-shaped curve which gets closer and closer to the x-axis or horizontal axis. And all the area is under that curve, and it's going to be 100%. Of course, the probability of any data being this far out is going to be very small. What's the probability that a data point will be greater than 2 standard deviations above the mean? Well, now we're looking at a point 2 standard deviations above the mean, and it would be the area to the right of 2 standard deviations. And that's going to be 2.35 plus the area out here. However, to figure that out, you know that 50% is to the left, and 34 plus 13.5 is between the mean and 2 sigma. So the rest is going to be out here. So the percent of the area greater than 2 standard deviations above the mean is going to be 100 minus the 50% plus 34 plus 13.5 equals 100 minus, let's see, 84, 13.5, which is 97.5. So that would be 2.5%. So the probability that the data point is greater than 2 standard deviations is going to be probability that X is more than 2 sigma is going to be equal to 0.025. The mean weight of a fish in a pond is 10 pounds with a standard deviation of 3 pounds. What is the probability that a random fish caught is between 13 and 16 pounds? Well, let's look at the standard curve here. If the mean is 10 pounds, 1 sigma is 13, 2 sigma is 16. So the probability that the fish is between 13 and 16 pounds, the area under the curve is 13.5%. So the probability of the fish being between 16 and 13 pounds is going to be 0.135. Now we have a normal distribution that has a mean of 500 and a standard deviation of 50. Find the z-score for a data value of 400. So x is equal to 400. The z-score is going to be x minus the mean divided by sigma, the standard deviation. Well, x is 400. The mean is 500. The sigma is 50. So this is minus 100 over 50, which is minus 2. So the z-score is minus 2. And finally, we're manufacturing a roller bearing for a large machine. The specification is that the mean diameter should be 2.2 inches. And the standard deviation coming off the assembly line should be 0.02 inches. And we want to complete the distribution chart below. Well, we basically know that the mean is 2.2. This is 1 standard deviation. So that would be 0.02. So this would be 2.22. 2 standard deviations would be 2.24. And 3 would be 2.26. Going to minus 1 sigma, we subtract 0.02 off, and we get 2.18. Subtract another 0.02, and we get 2.16. And subtract another, and we get 2.14. So here's the distribution of roller bearings coming off the assembly line. And that is practice test 4.